Okay, class. So today we're gonna come to section 4.2 Gaussian eliminations and backward substitutions. Okay, so we will learn about another way, or we call it another eliminations methods to solve the system. Okay, before doing that, let's we take a look at example 4.5 and solve for this one. Okay, so by the way, we learned before, we will try to make the opposite coefficients of a term to eliminate, right? So in this case, I would choose to eliminate term y, and I noted that if I multiply by 2 for the whole equation 2, I will make negative 4y. I can I can adding with the first one and make it become no more y. So so let's do that. I will have, let me type in here. The first one is not changed, but with 4y equal to 53. But the second one will be ax minus 4y equal to negative 20. And now we just gonna adding those together. So we have 11x equal to 33, right? So then we have x equal to 33 divided by 11 with x equal to 3. So so we have x equal to 3. We're gonna substitute x equal to 3 into any original equation. Let's choose equation 1. We have 3 times with 3 plus 4y equal to 53, right? So we will have simplify 9 plus with 4y equal to 53. And let's subtract 9 both sides. We will have 4y equal to 53 minus 9. And I got 4y equal to 44. So then y will be equal to 44 divided by 4. And that's, we have answer as y equal to 11. So solution is x comma y equal to 3 comma 11, right? So this is by using elimination methods, right? Okay, so let's develop the systematic way to solve system of equation. And we first as we cover a few mathematics operations, right, that allow to do on a system of equation and do not change the solution. So, okay, so these gonna be 3 things that you may have to remember with we call important operation with equations, and 3 very useful important operation called elementary operation. and that we can use on equation. So we can first interchain equation I and equation J, and symbol as you see over here is equation I with changing interchange with equation J with that symbols. And for examples, if I have equation 1 is here and equation 2 is here, so we're going to have interchange equation 1 with equation 2. We're going to be we will make x plus 2y plus 3z equal to 1, and 3x plus 5y minus 2z equal to 6. So as you see right now, equation 1 changed to be equation 2, and equation 2 now become equation 1. Like new equation 1, I mean that, right? So it will not make any change for the solution. Okay. Another operation that will not change the solution is multiply both sides of equation I with a non-zero constant k. So, and you see, if I multiply k with any equation and make a new equation, I will still have the same solution. So let's say if I multiply the whole equation over here with, say, number 4, let's say that, right? Okay, let me type it actually. Right. So what do we have for this one? We're going to have 12x plus 20y minus 8z equal to 4 times 6 is 24, all right? And again, you will not make any change for the solution. Lastly, we can replace equation J by the sum of equation J and K times equation I. So this operation, I will put 3 star in here because I say these operations can help us to eliminate variables. Okay, because what I do in here is I can using an equation and adding with another equation multiplied with a k to get a new equation, right? So for examples, if I say I multiply -3 with equation number 2 here, and adding with the equation 1. So what happened, right? So I'm gonna do like this. So equation 1, I adding with a -3 times with equation 2, right? So what happened? Okay, so let's calculate that. We have 3x plus 5y minus 2z equals 6. And that's the second one going to be -3x minus 6y and minus 9z equal to -3, right? So now you adding those together, you will have 0x minus y minus 11z equal to 3. Right? So as you see now, you have new equations, and that will make a new system as equation 1 stay as 3x plus 5y minus 2z equal to 6. But because we did change the new equation 2 to be negative y minus 11z equal to 3. So we have the second one without variables x. So no more term x in this case. Like I say, this operation can help us to eliminate a variable. Okay, so we will use these 3 operations in a systematic way to solve a system of equations. Okay. Let's move to example 4.6. Okay, so in 4.6, I consider the 3 equations where 3 are known as x, y, z, and they are variables. All right, and I didn't label them as E1, E2, and E3 here. Maybe I use the other color. All right. And I call this is 3 by 3 system. Since we have 3 equations with 3 unknown. 3 variables. Okay, so let's use equation 1 to eliminate x from the remaining equation. So I'm gonna say this step 1. So how to do that? You will have equation 1 was x plus y equal 12 here. So think about if you have you want to have new equation 2, you can say equation 2 you can rewrite as 2x plus y minus z equal to 3, right? And you need to adding something multiply with, or maybe just adding with something multiply with E1. So think about E1 was here. E1 was having x in here, right? You need to multiply a constant with x. So then later when you add them up, you will get no more x. So what do you think? -2, right? So -2 will need to multiply with E1. So then you will have -2 here, multiply with x. So then later you add this up together and make new equation 2 with no more x. Okay, so minus 2y. And do we have z? no z, right? So -2 times 0 is just 0 there. And you want to have equal to 12 times -2, which is -24. So adding together, you will have new equation 2. Okay, maybe I'm gonna move this a little bit. Okay, and you will have now no more x, y with negative y, you have negative y, and negative z equal to 3 minus 24 gonna be -21. So I'm gonna put down this guy to here, the new equation. I'm gonna move the y to be in the same column with the y. And no, we have to have the equal sign there. So we're just gonna move this a little bit. Okay. Maybe I'm gonna move this in the middle here. Okay. So nice. Okay, so so that we did have equation 2 minus 2 times equation 1, right? To get rid of x term in equation 2. So we have this guy. Yeah, maybe I put equal sign better, huh? Anyway, that's okay. Now we want to change equation 3. Put our equation 3 here. Right? You want to change equation 3. You need to add something multiply by equation 1, right? So as you see over there, I'm gonna move this one here so I can have more space. All right. So for equation 3, it was 3x minus y. I'm gonna use other color actually. 3x minus y and minus z equal to -9, right? So with equation 1, keep using equation 1 to eliminate it, right? So you know that it was x only. So if you want to eliminate the 3x here, you need to have -3 there, right? So if you want to have -3 here, you need to multiply by -3 for the E1, right? Okay. So now you have -3x and minus 3y. And no more z, so we have equal to 12 times with -3 gonna be -36. Okay, so now we can just adding those together. We will have 0x, -4y, -z, and then equal to -9 minus 36 will be -45. Okay, so we will have a new equation, new equation 3 will be this guy. Yeah. And I will just copy this down and put this one here. I will have equation 3 minus 3 equation 1. This was in green. And we have this. Move to here. Okay. This is good. All right. So this is system have been changed as new over here, right? Okay, now as you see, we did have no more x term for the remaining equations, right? Except only the equation 1, right? That is good. Okay, no more x term. Now we're gonna using equation 3 as equation 2 to eliminate y from equation 3. So we're gonna call tab 2. So we don't want to touch equation 1 anymore. We're going to use equation 2 to eliminate y from equation 3. Okay, so actually we change equation 3, right? So equation 3, we'll need to adding something multiplied by equation 2, right? So what is that? So let's write it out. So write equation 2 first. Equation 2 was no, actually, sorry. Right, equation 3 first. Equation 3 was negative y. Sorry, negative 3. It was 4y. 4y. Let's move this a little bit. We use this new one, okay? 4y minus z equal to negative 45. Okay, and I wanna add something with multiply by equation 2. Equation 2 now have negative y, and I want to make it 4y, so I can, when I adding those together, I can cancel. That's 4, right? So I need to multiply by 4 for this equation 2, the whole equation 2. So put 4 here, and then I have minus minus 4z, right? Because the equation was here, equation 2 was here, right? And equal to 4 times negative 21 will be negative 82. And we will have new equation 3. New equation 3. New equation 3 with no more y value, y variables, and we have only negative 5z equal to what is this gonna be? Oh, I make a mistake here. You see what I have new E3 is supposed to have a negative here, right? Okay, almost make a big mistake. Okay, so we have really watch out for each step. Okay, so this should be a negative 4, and that means I have to multiply by negative 4 in this case, and then so then I can, yeah, so I can get number 4y here, and I change it to be plus 4z And this will be 21 times 4 is 84, right? Okay, good. Now you can add them up and you got 39. This one going to be 3z. So you want to put this 3z over here. Equal to that. And so then that means I will have negative 4 times E2, right? And make it with that. So I will have, oh, I'm just going to say like minus 4 better to make it. Okay. Starter. Okay, now look at the system now. If you see the left-hand side and you draw a line, you draw like a, you draw 3 lines about the left-hand side of the system, you will see a right triangles here, right? Right triangles. Yeah. And the right-hand side is just a rectangles. So in this case, you will say that the system now is in triangular form. Okay, triangular form, and variables can be solved by substitution, backward substitution process. Okay, so we're trying to have a triangular form, and then we can have back substitution. And what is back substitution? So back substitution saying that you must start from equation 3, which is 3z equal to 39, and then you will solve for z. You have z equal to 39 divided by 3, with z equal to 13. So after that, you will go to equation 2 and substitute z into equation 2. And equation 2 was negative y minus z equal to negative 21, right? So now substitute with z equal to 13. So we have negative y minus 13 equal to negative 21. And that means y will be equal, negative y will be equal to negative 21 plus 13, which is equal to negative 8, right? So I'll say like negative 21 plus 13. So then we have, let's say, y equal to negative 8, negative y equal to negative 8. And you will just, just multiply by negative 1 both sides, you will get y equal to 8. Okay. Lastly, you will substitute x equal to 13 and maybe actually let's just write E1 and was x plus y equal to 12, and we substitute y in there. X equal to x plus y now equal to 8 and equal to 12. That's give us x equal to 12 minus 8, which is 4. So that means solution is informed as x comma y comma z, which is 4 comma 8 comma 13. And what kind of solution is this? Is it independent, dependent, or inconsistent? So this is clearly we have only one solution. So we're gonna say independent. And because we have only one solution. Does that make sense? Okay, so that is the way using Gaussian eliminations and back substitutes to solve for this system. Okay, and now let's have an exercise to check if it is a triangular system. So we have, if we have 4.6 here, and the left-hand side you draw a 3 line to bound the left-hand side, and you will see this is the right triangles. All right, so you will say yes, this is triangular system, and you don't have to say why not, because it is yes, right? Okay. So I would like to ask you to practice with 4.7. Go ahead and pause my videos and try it in 5 minutes, and then after that replay play it and to see the answer and compare the solution with me. Okay, so for step 1, in order to use E1 to eliminate x from the remaining equations, and you see here what I did is for the new equation number 2, I just do the original one minus with E1, right? And I got y plus 6z and equal to 20, right? And for the y for the equation number 3 there, I don't have to do anything since it has been eliminated the x term already. So I will just have y plus 9z equal to 29. Okay, go ahead and try to use try to do step 2, which is use the second equation to eliminate the y term from the final equation. Okay, so go ahead and pause my videos and do that. Okay, as you can see now, after you do equation 3 minus for equation 2, you will have new equation 3 as 3z equals to 9, and now you can draw 3 lines about the left hand side of the system. You will see we have triangular system, and because that we can go ahead and back substitutes. Okay, so substitutes. So we're gonna start with E3, which is 3z equal to 9, and we have z equal to 9 divided by 3, which equals to 3. And then we come to equation 2, which is y plus with 6z equal 20, and we substitute z equal to 3. In there, we have y plus 6 times 3 will equal 20, and then simplify, you will have y plus with 18 equal 20. So then you can subtract 18 both sides, and you have y equal to 2. Okay, so now the last one for E1, I have x plus 2y plus 3z equal to 18. And so then I can substitute everything ends. X times y are going to be equal to 2. And plus with 3 times with z is 3 now and equal to 18. So then we will have this as let's simplify this. X plus with 4 plus with 9 equal to 18. So then we have x equal to 18 minus 4 minus 9 is 5. So solution is anti-color. I will say x comma y comma z, and that's equal to 5 comma 2 comma 3 as answer. Okay, so we have finished this exercise by Gaussian eliminations and using the back substitutes of that. Now we're gonna learn about now we have exercise 4.8. You can go ahead and try to work on this and pause my video in 5 minutes and compare with me, okay? Okay, so hopefully you did get into this step. After getting eliminate equation number 2, x term, you come to eliminate x term in equation 3. However, you after doing it, you noted that all the left-hand side becomes 0, and the right-hand side adding, you get number 1. So you end up with the equation say 0 equal to 1, which means no, it is not true, right? Not true statement. So then we're gonna say no solution. And we can say it is inconsistent. Okay, so this will be the answer for this part. Okay. So let's we go ahead and move down here. Think well. Try to label each of these linear system as independent, dependent, or inconsistent, right? So you know that's the intersection, the one have intersections will be the independent one, right? Dependent. And you know that's the one that's parallels will be inconsistent. And the last one have overlap. We're gonna be dependent. So that's going to be it for section 4.2. I will stop the the video here. We'll see you in the next section.